In our previous class, we went through all of the naming conventions for naming ionic compounds. Now we're going to focus on naming molecular compounds, and these ones are a little bit different, but they're actually a little bit more simple than naming ionic compounds. So the first thing that I want you to do is I want you to ask yourself, whenever you see a compound that you're trying to name, is it a metal and a nonmetal, or is it only nonmetals? And if it's only nonmetals, you're going to use the molecular compounds naming conventions. So remember, only nonmetals. So again, these naming conventions are just a little bit simpler. You're just going to use the prefix plus the name of the first element plus another prefix plus the base name of the second element. Remember, we learned about these when we were studying the ionic compounds. And then we go back to our IDE ending. So what does this look like? Let's say that we have NO2. Notice those are both nitrogen and oxygen are both nonmetals, so we're going to use this molecular naming convention. And this is going to be called nitrogen dioxide. So notice there's only one nitrogen. We usually leave the prefix off when it's the first element, if there's only one of them. So we don't use mono if there's only one of the first element. We just write the name of the first element. But then we have the name of the first element, and then we have the prefix of the second element. So we have di, meaning two. So notice that there are two oxygens. And then we have our oxide. So that is the base name of the second element plus our IDE end. So alternatively, we could have N2O. In this case, there are two nitrogens, so two of the first element, and that means that we do actually have to write the prefix for that name of the first element. So that is going to be dinitrogen. And then we do use the mono prefix for one of the second element. That's going to be monoxide. Also, notice how we don't write monoxide. We don't repeat the O's, so when there are two O's next to each other, we just drop one of them, so it becomes monoxide. So let's do a couple of examples. So go ahead and pause the video here, solve them on your own, and then we will check them as a group. So for this first one, we have nitrogen. So this is like our first example where we leave the mono off the first element when there's only one of them. And then we have triiodide. And this one's a little bit confusing because even though we only use one O, we actually do use both of the I's. So the more you see, the more examples of these that you see and the more you practice them, the more you'll be able to recognize when you form contractions between the prefixes and the base name of those elements. So for our second example, this one doesn't only have one of our first element, we have four. So in chemistry, we use the prefix tetra for 4. So we have tetraphosphorus, deca sulfide. Deca is the prefix for 10, and then we have sulfide. And then notice that when you are spelling phosphorus, when you're spelling the element name, it's just US. OUS is for something entirely different. So this is an example of where spelling does matter. So there are certain types of molecular compounds that are named in a slightly different way just because the way that they behave as compounds is very specific, and these are acids. So there are 2 main types of acids, and the first ones are binary acids, and these contain only 2 elements. And when we have an acid, at least at this point in the class, we're going to consider an acid as anything that can give up an H+. We're going to learn a little bit more about that later on in the semester, but for now, an acid is just anything that can release an H+ when it breaks apart. So that is going to be HCl, HF, HBr, HI. And these are our binary acids. So notice that these are really special. Remember that hydrogen is in the first column of the periodic table. It's in group 1, which means that even though it's a nonmetal, in some ways it kind of behaves like the group 1 metals. So it can actually form an ion even though it is considered to be even though it's considered to be a nonmetal, it can actually form an H+. So acids are special because they're kind of in the middle, like somewhere in between ionic and molecular compounds, and we have to take that into account when we're naming them. So we have a slightly different naming convention for our binary acids. So what we do is we say hydro plus the base name of the nonmetal. And by nonmetal, I mean the one that is forming an anion. So I'll call it the base name of the anion to be more specific, since hydrogen is technically also a nonmetal. Plus IC plus the word acid. So that means for HCl, we have hydro. Base name of the anion is chlor, CHLOR, plus IC, hydrochloric acid. That means that HF is hydrofluoric. And remember that this is FLUORIC, acid. And then take a minute on your own to fill in HBr and HI using these naming conventions. So HBr is going to be hydrobromic acid, and then HI is going to be hydroiodic acid. So that's how you name the binary acids. There's one other type of acid that we're going to be looking at right now, and those are going to be the oxyacids, and oxyacids are any acids that contain oxyanions. So remember the oxyanions from our lessons on ionic naming conventions. Remember that oxyanions are a type of polyatomic ion containing oxygen. So some examples of some oxyacids are HNO3, so that would be an H plus and an NO3 minus. Remember, NO3 is our nitrate. And then we have HClO2. It's another example. So do you have a guess as to what that one is called? We have our H plus, ClO2 minus. So remember that ClO2 minus has one fewer oxygen than the chlorate you were asked to memorize. So that means that this is our chlorite. And that's going to be very important in how we name these, because depending on the name of the oxyanion, we name the acid a little bit differently. So remember, this one is nitrate, has an ATE ending. Then we have chlorite, it has an ITE ending. So now how do we name these acids? When we have an ATE ending, we're going to say the base name of the oxyanion, plus IC, plus acid, which means that for HNO3, because it uses the nitrate anion, that means that HNO3 is going to be nitric acid. So that's the base name of the oxyanion, so that's this part here, and then the IC acid. Another example would be HClO4. So remember that ClO4 minus is chlor, or excuse me, it's chlorate, because it has one more oxygen than chlorate. So the name of HClO4 is going to be called perchloric acid. So that's if we have an ATE ending. What if we have an ITE ending, like chlorite? In this case, we're going to use the base name of the oxyanion again, but instead of using IC, we're going to add OUS plus acid. So that means that our HClO2 is going to be chlorous acid. So let's do another example. Let's say that we have HNO2. So notice that NO2 minus would have one fewer oxygen than NO3 minus, which means that this is going to be nitrite. And since it has an ITE ending, we name this acid as nitrous, O-U-S, acid.